The missile is already committed. You cannot hear it at first, just the faint hiss of the sea wind across the deck, then a low, growing roar that makes the metal under your boots feel alive. On the combat screen, the track is a bright, impatient line rushing straight toward the ship, numbers collapsing fast, range, time, impact. Then, off the starboard bow, a small drone lifts into the sky like a firefly, leaving a porch light. It does not fly away in panic. It flies with purpose, sliding into the missile's attention like it belongs there, and the missile's nose twitches, then snaps, then commits to the wrong thing. A hard turn, a hungry dive, a final sprint, and the warhead detonates over empty water, close enough to sting, far enough to live. In that half second, you learn the new rule of naval survival. Sometimes you do not win by being stronger, you win by being more confusing. This is Battletech Declassified. Modern Warfare Explained. Today's episode is simple to say and brutal to execute. How decoy drones make enemy missiles miss. Not maybe miss, not reduce probability, but miss in a way that flips the whole fight. Because every missile that chases a ghost is a missile that does not force you to spend a real interceptor. We are going to break it down like a magic trick. First, the secret, then the hidden wires, then why the magician sometimes gets shot anyway. We'll cover what missiles actually see, what decoy drones can fake, what is hard to fake, and the chess match that starts the moment your decoy turns on. And near the end, we'll connect it to the bigger counter-swarm playbook, because decoys are not a standalone shield. They are a tool that buys time for the rest of your defense to breathe. Think of a missile like a bloodhound with a jet engine. It does not hate your ship. It follows a scent trail of signals, radar reflections, heat, radio noise, sometimes even a picture-like silhouette. If the scent is strong and clean, it runs straight. If the scent splits into two trails, it chooses the trail that feels most real. A decoy drone is a portable scent factory, a flying liar that whispers to the missile, "I'm the ship, louder than the ship can." The best decoys do not just distract, they seduce. They become the most delicious target in the missile's universe for the last few seconds when it matters most. Here is the key idea. Missiles are fast, but their certainty is fragile. They are built to solve a targeting problem under time pressure, with limited sensing and imperfect information, and that makes them vulnerable to a well-timed lie. When you understand that, decoy drones stop feeling like extra gear and start feeling like a new layer of armor that you can move around. But there is a catch. Decoys do not remove danger. They relocate it. You are deciding where the explosion happens, and you only get that choice if you put the decoy in the right place, at the right time, with the right kind of fake signature. That is the difference between a decoy drone that saves a ship and a decoy drone that becomes a useless spark in the sky. To understand how to fool a missile, you have to know how it hunts, and it hunts in phases. In the early phase, many missiles fly on inertial navigation, basically a high-speed memory of where they are supposed to go, plus occasional course updates from a launcher, an aircraft, a ship, or another sensor network. In that phase, the missile is not looking, it is traveling. Then, as it gets close enough, it switches to terminal guidance, the moment the seeker wakes up and the missile becomes a predator with eyes. That terminal moment is where decoy drones earn their keep, because it is when the missile makes its final commitment. Different missiles see differently. Some use active radar. They transmit and listen for reflections, like yelling in a cave and mapping the echoes. Some use passive radar homing. They listen for your radar emissions like a thief listening for footsteps. Some use infrared. They chase heat like a snake sensing warmth. Modern threats often combine multiple modes, radar plus infrared, sometimes with imaging that tries to recognize a target's shape. The more modes, the harder it is to fool, but also the more ways the missile can be overloaded with conflicting clues. What we know for sure is the seeker is trying to lock onto a track that looks stable and true. What we do not know, and often cannot know, is the exact classified logic inside each seeker, the filters, the thresholds, the anti-jam tricks. So we will focus on the physics and the patterns, because physics is the one thing you can actually plan around. Let's start with radar seekers, because radar is the classic way missiles find big ships. A ship has a radar cross-section, basically how big it looks to radar, not in meters, but in reflected energy. A destroyer can look huge, a floating city of metal angles. A decoy drone can cheat this by carrying passive reflectors, like corner reflectors, that bounce radar energy back efficiently, making a small drone look like a much larger object. But passive tricks only go so far, because a real ship does not just reflect, it has complex patterns, changing with angle, motion, and sea clutter. That is why more advanced decoy drones use active deception. Instead of just reflecting radar, they transmit signals that mimic a ship's radar, fingerprint, sometimes repeating the enemy's own radar pulse back with a slight delay. Like throwing an echo that arrives from the wrong place. If done well, the missile's radar sees a target where the drone wants it to see a target, with a range, speed, and strength that feel believable. Imagine a video game where you can spawn a fake boss with the same health bar and movement style as the real boss, and the enemy's aim assist snaps to it. That is the seduction. The danger is timing and credibility. If the fake appears too late, too early, too bright, or too weird, the seeker may reject it, and then you have announced your trick without buying any safety. Now the infrared world. Heat seekers. A missile with an IR seeker is not impressed by shiny metal. It is hungry for warmth, engines, exhaust, hot decks, fires, even sunlight heating surfaces. A ship can be a messy heat source, multiple hotspots, funnels, turbines, electronics, and a warm wake. A decoy drone has to offer an IR story that makes sense. Either it looks like a ship's hottest part, or it looks like a separate valuable target the missile is allowed to choose instead. The simplest IR deception is a flare, bright, brief, and violent. But flares burn out quickly and do not move like a ship. Decoy drones change the game because they can carry heat and move with intent. They can tow a hot source, carry a burner, or use materials designed to glow in the right wavelengths. They can also behave like a plausible target, moving steadily, not twitching like a flare, staying in the seeker's field of view long enough to drag the missile off the ship's track. Think of it like luring a guard dog away with a stake on a remote control car. The stake is real, the dog's desire is real, and the car can lead it where you want. But IR deception has limits, especially against imaging infrared seekers that look at shapes and patterns. A bright dot is easy. A believable ship silhouette is hard. And if the sea background is cold and your decoy is blazing hot, you might be too obvious, like a flashlight in a dark room. The modern nightmare is the multi-mode seeker, the missile that cross-checks radar and infrared, and sometimes adds passive RF sensing, and sometimes adds an imaging brain that tries to recognize what a ship should look like. This is like trying to lie to a person who can hear your voice, see your face, read your body language, and check your ID. Your decoy drone now has to lie consistently across multiple senses, or at least create enough confusion that the missile's certainty collapses and it chooses wrong. That is why decoy drones are not just a gadget, they are a system, designed for a specific threat set. Here is the practical lesson. You do not need perfect deception to win. You need deception that works during the missile's decision window. That window can be seconds, sometimes less, and it is when the seeker locks, refines, and commits to a final aim point. If you can create a more attractive, more stable, more target-like solution during that moment, you win the guidance battle even if your decoy would fail a laboratory test. This is also where tactics matter as much as technology. A mediocre decoy flown perfectly can beat a great decoy flown badly. Because the missile is not scoring you on elegance, it is scoring you on whether its guidance loop stays happy. Smooth tracking, believable motion, consistent returns. Break that happiness at the right time, and the missile misses. Let's talk about the nastiest form of deception, coherent false targets, the kind that makes radar seekers swear they are seeing something that is not there. One method uses digital radio frequency memory, DRFM, which is a fancy way of saying you record the enemy radar pulse, then replay it back with controlled changes, delay it, shift it, multiply it. So the radar thinks the echo came from somewhere else. The missile seeker is trying to measure range, angle, and sometimes speed. If you can feed it a consistent lie about those measurements, you can pull the seeker's track off the ship. Two classic tricks are range gate pull-off and velocity gate pull-off. In simple terms, the seeker has a little box where it expects the target to be in range and speed. Your deception slowly drags that box away, like slowly moving a magnet under a compass needle until the needle follows. The missile thinks it is still locked because the tracking looks smooth, but the lock has been stolen. A decoy drone is an ideal platform for this because it can position itself where the false target needs to be and keep the geometry believable. But again, there is a duel happening. Missiles can have anti-jam features, and some can even home on jamming, chasing the source of the lie. So the decoy drone sometimes has to be willing to die loudly because its job is to be the loudest liar in the room, long enough for the ship to survive. There are two big ways decoys make missiles miss: distraction and seduction. Distraction is the simple version. Throw noise, throw heat, throw something shiny, and hope the missile snaps to it. Seduction is the adult version. You do not just distract the missile, you convince it that your decoy is the best solution to its guidance problem. Seduction is about track quality. If the missile's tracking loop is a little engine that wants smoothness, you feed it smoothness. If it wants a stable aim point, you give it a stable aim point. If it is comparing options, you make your option easier to track than the ship. This is why decoy drones can outperform traditional expendable countermeasures in some scenarios. A flare is a scream. A decoy drone is a conversation. The drone can keep the seeker engaged, maintain angle, maintain range, and stay within the seeker's field of view as the missile closes. It can also adapt, changing speed, altitude, and signature based on what the ship's sensors see. But seduction also requires discipline, because if your decoy drone makes a move that looks impossible for a ship, like a sharp vertical climb at the last second, the seeker may say, "That's not a ship," and switch back. So the drone often has to fly like a ship would move. If ships could fly, steady, heavy, predictable, the lie must feel boring, because boring is believable. Timing is everything. Launch a decoy too early and the enemy may spot it, classify it, and adjust. Or the missile might not even be in terminal mode yet, so you waste your best trick before the decision window. Launch too late and the missile is already locked hard. Its seeker is confident, and your decoy becomes a late whisper against a loud truth. The best timing is when the missile transitions from mid-course to terminal, when it is hungry for a lock and still willing to accept a new story. That moment is not always obvious, but your sensors, your electronic support measures, and your combat system can often infer it from behavior. Placement is just as critical. If the decoy drone is too close to the ship, the missile may still detonate close enough to cause damage, even if it misses direct impact. If the decoy is too far, the seeker might not see it in time, or the geometry might make the switch unlikely. A common goal is to pull the missile's aim point away so the warhead detonates where fragments and blast are mostly wasted into air and sea. You are sculpting the explosion. Picture a boxer who cannot stop every punch, but can turn their shoulder so the punch lands on muscle instead of the jaw. That is decoy geometry. The drone is the shoulder turn. And if you want this to work repeatedly, you need a playbook, launch corridors, holding patterns, and rules for when to sacrifice a decoy versus when to save it for the next inbound. Now put this into the warship's reality. A ship has limited interceptors. Even a well-armed destroyer cannot shoot down an unlimited number of incoming threats, and the attacker knows it. That is the entire logic of saturation. Force the defender to spend expensive missiles until the magazine runs dry, then finish the job. Decoy drones attack that logic at its root. They let the defender trade cheap airframes for expensive enemy munitions, and they do it without consuming the ship's hard kill inventory. It is like having a stack of fake keys that make the burglar's lockpicks break. Decoys also buy time, and time is what layered defense needs. Your radar needs time to track. Your combat system needs time to decide. Your launchers need time to reload. Your close-in weapons need time to get a firing solution. A decoy drone that pulls one missile off the ship can also create a ripple effect because the defense can now focus on the next track, the next threat, with more calm and more options. But it only works if the decoy is integrated, not just stored. You need training, procedures, and clear authority, because in a real attack, there is no time for a committee. Someone has to press launch decoy, someone has to assign it a mission, and someone has to accept the moment it becomes a sacrificial piece. The ship that treats decoys like an afterthought discovers they are just expensive clutter. The ship that trains them like a weapon discovers they are survival. Decoy drones become even more important when the attacker mixes threats, missiles, drones, maybe even loitering munitions. The goal is to overload not just your interceptors, but your attention. When you have 10 inbound tracks and only seconds to sort them, you are fighting a cognition war. Decoy drones can simplify that war by turning some of the attacker's weapons into self-defeating problems. If an incoming missile can be seduced away, you do not need to dedicate a precious interceptor to it, and that frees capacity for the threats that cannot be fooled. This is the deeper point. Decoy drones are a form of battlefield accounting. They convert the attacker's expensive certainty into expensive doubt, and doubt is contagious. If the attacker knows you have credible decoys, they may need to fire more missiles to achieve the same probability of kill, which increases their cost and can expose their launch platforms. They might also be forced to adjust seeker modes, fly different profiles, or delay terminal activation, all of which create new vulnerabilities. But there is no free lunch. Every decoy drone you launch is also a signal, an emission, a pattern, a clue. Over time, the attacker learns. So decoy warfare is not a one-time trick. It is an evolving deception campaign where you rotate tactics, change signatures, and sometimes deliberately look imperfect so the enemy cannot build a reliable filter against you. Let's face the enemy's side of the chessboard. Modern missiles are not stupid. They can use home-on-jam modes, meaning if you shout too loudly with jamming, the missile may simply steer toward the source of the shout. They can use multi-mode switching, meaning if radar gets weird, switch to infrared, and vice versa. They can use track validation, comparing what they see to what they expect a ship to do. Some can even coordinate with other sensors, receiving updates that help them ignore decoys. This is why decoy drones are moving towards stealthier deception, not always louder, sometimes smarter. So how do you beat a missile that learns? You exploit constraints. A missile still has physics. It can only turn so hard. It can only see through so much clutter. It can only process so many competing targets before its confidence drops. A decoy drone can also be designed to trigger the missile's trust routines, offering a stable return and smooth motion that looks like a ship's inertial behavior. And you can play the probability game. You do not need every missile to be fooled. You need enough missiles to be fooled that your hard kill layer can handle what remains. That is the uncomfortable truth of modern defense. It is not about perfect shields. It is about surviving the wave. Decoy drones are one of the best tools for reducing the wave's effective mass because they remove some threats without spending your magazine. Now the part that feels almost unfair, the kinematics trap. Missiles are fast, but speed does not equal agility. At high speed, turning costs energy. The missile's guidance law is trying to steer toward where the target will be, not where it is, and that prediction can be manipulated. If a decoy drone can create a target track that demands a hard, continuous turn, the missile can be forced into a bleed, losing speed and control authority. Even if it does not miss immediately, it may arrive late, slow, and less lethal, or it may fail to fuse at the right distance. This is why decoy drones often aim to pull missiles sideways, not just away. Imagine you are running, and someone tries to grab you. The easiest way to escape is not to run straight away. It is to make them turn sharply while you cut smoothly. The missile has to follow its guidance loop. If the decoy drone can lead it into a geometry where the missile's best intercept solution is constantly shifting, you can create a miss even without perfect signature deception. The seeker sees you, the guidance tries, but the math becomes painful. This is also why altitude and aspect matter. Pulling a sea-skimming missile up can expose it to different defenses and increase the chance it loses lock over the water's messy radar reflections. Pulling it down can force premature detonation into the sea. The decoy is not only lying, it is steering the missile into bad options. Here is where decoy drones start looking like a swarm on your side. One decoy drone can be good, multiple decoy drones can be art. If 2 or 3 drones coordinate, they can present multiple false targets, shifting relative strengths, trading the seeker's attention back and forth, like street magicians with 3 cups and 1 ball. The missile's seeker has limited processing and finite time. Give it too many plausible choices, and it can either pick wrong or hesitate long enough that it fails. This is not guaranteed, but it is a real design strategy. Saturate the seeker the way the attacker saturates the defender. Coordination can also create distributed signatures. One drone handles radar deception, another provides an infrared lure, a third acts as a stand-in jammer. From the missile's perspective, those signals can merge into a single target if the geometry is right, producing a composite lie that is stronger than any single drone could deliver. The hard part is choreography, because if your signals do not line up in time and space, the seeker may detect inconsistencies, and then the whole illusion collapses. This is why autonomy becomes tempting. Humans are great at strategy and terrible at sub-second choreography. A defense AI can adjust decoy positions and emissions in real time, keeping the lie coherent as the missile closes. But autonomy adds risk, because the wrong behavior can create a pattern the enemy can learn, and the wrong emission can also reveal your own sensor methods. So, even in decoy warfare, you are balancing speed against secrecy. Let's talk about the operator's nightmare, the control problem. In a real fight, the ship is managing radar, electronic warfare, interceptors, close-in guns, damage control, and communications. Decoy drones add another moving piece, and if that piece demands constant manual attention, it will fail at the worst moment. The future of decoy drones is not more buttons. It is simpler intent-based control. You do not fly the drone like a hobbyist. You assign it a job. Be a ship over there. Pull that missile away. Jam that seeker, and it executes within safe constraints. This is where the phrase "human in the loop" becomes complicated. A human must decide when to sacrifice a decoy, because that is a strategic choice. But a machine should handle the micro-timing, because that is a reflex choice. If you force humans to do reflex work, you get latency, hesitation, and mistakes, and the missile does not forgive hesitation. So the winning model is layered. Humans set rules and priorities. Machines execute tactics inside those rules. That also creates accountability. If the decoy drone makes a decision you did not intend, you need to know why, and you need to be able to change the rules quickly. Otherwise, you do not have a defense. You have a haunted system that might save you today and betray you tomorrow. Decoy drones are only as good as the trust you have in their behavior under pressure. You might be wondering, is this real, or is it sci-fi? The truth is, decoy concepts have existed for decades. Flares, chaff, towed decoys, standoff jammers, and air-launched decoys that mimic aircraft. What changes now is mobility and persistence. A drone can be launched quickly, maneuver into an optimal geometry, adapt emissions, and stay alive long enough to manage multiple inbound threats, or at least shape the engagement. Even when the specific details are classified, the broad direction is clear, moving deception from disposable bursts into maneuvering assets. Also, decoys are not only defensive. If you can deploy decoy drones offensively, you can confuse enemy air defenses, trigger their radars, waste their interceptors, and expose their positions. But for ships under missile attack, the defensive use is the urgent one, and we should be careful with claims. Decoys do not guarantee misses, especially against advanced seekers with strong countermeasures. They increase survival odds by bending the fight into a probability game that favors the defender's economy, if the defender trains and integrates them. The biggest failure mode is assuming technology alone is enough. A decoy drone is not a magic shield. It is a tool that works when your sensors can detect early, your command system can decide fast, and your tactics place the decoy where the missile's decision loop can be hijacked. That is the real story. Not miracle gadgets, but disciplined deception under fire. Now the cost math, because cost is the quiet engine behind most modern warfare. If the attacker fires a $1 million missile and you defeat it with a decoy drone that costs a fraction of that, you have forced a bad trade on the attacker. But cost is not just sticker price. It is manufacturing, logistics, training, maintenance, and the opportunity cost of carrying decoys instead of other stores. The best decoy drones are designed for scalable production and simple operation, because if they are too precious, commanders will hesitate to use them, and hesitation kills ships. There is also the attacker's response. They may start firing paired missiles, one to force you to reveal your decoy, another to strike after the decoy is spent. They may time attacks to drain your decoy inventory the way they try to drain your interceptor inventory. That is why decoys must be part of a layered defense economy, not the only pillar. A good defense uses decoys to reduce pressure on hard kill systems, then uses hard kill systems to cover decoy weaknesses, and uses electronic warfare to make both more effective. It is like a castle defense. Moats, walls, archers, and traps. No single element is perfect, but together they create a killing puzzle for the attacker. When decoy drones are used well, they do not just stop missiles. They change the attacker's planning calculus, because the clean, predictable path to a kill becomes messy, expensive, and uncertain. So what does the decoy drone future look like? It looks like a cloud of ghost targets that can be summoned on demand, pushed out from the ship, and shaped into a moving shield of confusion. It looks like decoy drones that are not just decoys, but also sensors, relays, and intercept coordinators, so every decoy launched also extends your awareness. It looks like signature libraries that can be updated quickly, so your drones can mimic different ship types, different heat patterns, different radar behaviors, making the enemy's seeker logic chase a shifting target. And it looks like tight integration with the rest of the kill chain, because decoys are most powerful when they buy you the one thing defenses always need: time. But it also looks like a new arms race: deception versus validation. The enemy will build seekers that distrust obvious lies, and defenders will build lies that feel boringly true. That duel will not be settled by one breakthrough. It will be settled by systems, training, and iteration. The final takeaway for this episode is simple. Missiles miss when their certainty breaks at the wrong moment. And decoy drones are one of the best tools we have for breaking that certainty without spending our own hard kill magazine. Next, we'll take the next step in the same puzzle. Because once you start lying to the enemy's seeker, the enemy starts lying back, feeding you poison tracks, phantom targets, false confidence. That's where sensor fusion becomes the difference between seeing reality and seeing a trap. Imagine the attack now from the bridge of a destroyer at dusk. The sea is dark glass, with streaks of orange fading into steel blue. The wind is colder, and the horizon is so clean it almost feels fake. Then the tactical display blooms. First one inbound, then 3, then 7. Some are real anti-ship missiles. Some may be drones. Some may be noise. The captain does not have the luxury of solving the puzzle perfectly. The crew has seconds to decide what gets jammed, what gets shot, and what gets lured away. This is where decoy drones stop being a theory and become a survival drill, because every second spent arguing is a second the enemy keeps for free. The first decoy launches low and fast, not dramatic, just a small violent shove into the air, then a clean bank away from the ship. On the screen, one inbound track begins to wobble. That wobble is everything. It means the missile's confidence is no longer absolute. A second decoy launches on a different bearing, not because 2 decoys are always needed, but because modern defense is about keeping options alive. One missile follows the false track outward. Another stays committed. That is the brutal truth of the engagement. Decoys do not erase danger, they thin it. But thinning the wave is how ships live now. Not by pretending every threat can be killed, but by making sure not every threat must be killed by steel-on-steel interceptors. Sea-skimming missiles make this harder because they live inside clutter. The surface of the ocean is not a clean background. It is a moving sheet of reflections, wave tops, spray, thermal patches, and false glints that can help both sides. For the missile seeker, clutter can hide a decoy or expose one, depending on angle and altitude. For the defender, clutter is both camouflage and chaos. A decoy drone that flies too high may look unnatural. A decoy drone that flies too low may disappear into the mess. The best deception often happens right at the edge, where the seeker's certainty is most fragile and the environment does half the lying for you. That is why altitude control matters as much as emissions. A good decoy drone does not just radiate, it stages a scene. It places itself where sea clutter can blur the line between target and ghost. forcing the missile's guidance loop to work harder than it wants to. If the seeker has to constantly separate real returns from messy background, while also reacting to a coherent false target, you are not just tricking it, you are exhausting it. Think of it like trying to identify one voice in a crowded train station while someone beside you keeps repeating the same sentence in the same accent. Sooner or later, your brain grabs the wrong speaker. That is what the decoy wants. Not theatrical brilliance, just enough believable confusion to make the missile spend its final seconds believing the wrong story. Weather changes the game too. Rain can weaken some radar effects. Humidity can change infrared contrast. Haze can flatten depth cues. Wind can push a small drone just enough to ruin what looked perfect on a clean range test. In a brochure, deception looks elegant. In weather, it becomes ugly, noisy, and full of compromise. That is why the best decoy doctrine does not depend on one perfect profile. It builds families of tactics, different launch distances, different emission strengths, different flight behaviors, all chosen to fit the air, sea, and threat picture of that moment. A rainy night might favor one kind of radar lie. A dry, cold dawn might favor an infrared lure. Heavy sea state may make low flight dangerous for the drone but helpful for confusing the seeker. The crew has to think like gamblers and engineers at the same time, asking not, what is the coolest trick, but what gives us the best odds right now? This is the quiet theme running through the whole episode. Modern defense is less about heroic certainty and more about probability management under pressure. The ship is not choosing between perfect answers. It is choosing which imperfection gives it the most survival. Decoy drones belong in that world because they are flexible, movable imperfection, a way to reshape bad odds into merely dangerous odds. Now think about the attacker learning in real time. If the first missile misses because it chased a decoy, the next salvo may not behave the same way. The enemy may stagger seeker activation, compare terminal tracks, or use one missile to expose the decoy and another to stay silent until late. That means the defense cannot run the same script over and over. If your deception becomes predictable, it stops being deception and becomes just another visible layer in the enemy's planning map. So the defender needs variation. Sometimes the decoy launches early and behaves like a displaced capital target. Sometimes it launches late and acts like a hot fragment of the ship. Sometimes it does not transmit much at all until the final seconds. Sometimes it works in combination with onboard jamming, so the seeker never gets a clean baseline. The important part is that the enemy never gets to say, I know what this Navy does. Good decoy doctrine is like good boxing. Same fundamentals, different combinations, always enough unpredictability that the opponent can't settle into a rhythm. The moment the attacker begins to anticipate your lie, you need a new lie ready, or at least a new timing, a new geometry, a new way to make the seeker doubt what it thinks it knows. This is where training becomes more important than raw technology. A brilliant decoy drone in the hands of an unpracticed crew is like a fire extinguisher still in the box while the kitchen burns. The team has to rehearse launch windows, roles, fallback decisions, and communication discipline until the actions feel boring. Boring is good. Boring means muscle memory. In a real missile engagement, there is no time to debate whose console owns the drone, who authorizes emissions, or whether the second inbound is really more dangerous than the first. Those decisions have to already exist before the attack begins. The best crews would train decoy use the way pilots train engine failure, not as a rare gadget event, but as a normal part of ship defense. That means running mixed scenarios where some decoys work and some do not. It means teaching crews to trust the system without worshiping it, and it means after-action review that is brutally honest. If the drone launched too late, say it. If the geometry was wrong, say it. If someone clung to a hard kill solution because they did not trust deception, say that too. Warfare has a cruel way of exposing private doubts in public explosions. Better to discover those doubts in training than in the last 20 seconds before impact. There is also a command philosophy hiding inside all this. For decades, naval defense has often been framed as a contest of detection, classification, and interception. See the threat early, label it correctly, shoot it down. Decoy drones add a fourth verb, mislead it. That sounds small, but it changes the whole mindset. Instead of treating every inbound as something that must be physically destroyed, Commanders can start asking a cheaper question first. Can we make this weapon waste itself? That shift matters, because modern missile warfare is becoming a contest of inventory and tempo. If the enemy can make you fire $1 million response at every incoming track, they can bleed you dry even without landing a hit. But if you can mislead part of the salvo, hard kill the most dangerous part, and absorb the remainder with layered defenses, you reverse the pressure. The enemy now has to wonder how many rounds they need for one credible kill, and the answer may become ugly enough that their whole attack plan starts to wobble. This is how doctrine changes, not because one gadget is magical, but because one new tool changes the economics of the fight enough to rewrite what good tactics mean. We also need to talk about decoy drones as forward assets, not just emergency lifeboats thrown into the air during the last seconds. A ship could keep drones already orbiting at useful distances, extending both sensor coverage and deception options before an inbound even reaches terminal range. That means the drone is not scrambling from zero. It is already sitting in a place where it can become a false target, a relay, or a spotter almost instantly. The defender stops reacting from the ship outward and starts shaping the battle space farther away. That is a big deal, because distance is time. And time is the one thing every defense layer needs. A forward decoy drone could help pull a missile off axis earlier, forcing it to waste energy before it even reaches the inner defensive rings. Or it could help the ship identify which missiles are seeker active, which are still coasting, and which ones are acting strangely. In other words, the decoy may also become a witness. It does not just lie to the enemy, it helps tell the truth to the defender. And once a system can both deceive and observe, it stops being a simple expendable and starts becoming a central node in the ship's survival architecture. But every new node is a new vulnerability. If the enemy can hack, jam, spoof, or simply destroy your decoy drones early, then your moving shield collapses before it matters. That means resilience has to be built in from the start. Autonomy if links fail, simple fallback behaviors, hardened communications, and mission logic that does not require constant hand-holding from the ship. A decoy drone that becomes useless the moment its data link flickers is not a shield, it is just future debris. Redundancy matters here. You do not bet the ship on one perfect drone, one perfect link, or one perfect tactic. You build enough low-cost redundancy that losing one piece does not collapse the plan. That is the same logic that drives distributed fleets and distributed sensors. Single points of failure are a luxury of peacetime thinking. Wartime systems must expect partial blindness, partial confusion, and partial loss, then keep functioning anyway. So the most dangerous decoy drone network is not the fanciest one. It is the one that still tells believable lies after getting punched in the face. That kind of resilience is not glamorous, but it is exactly what separates demo day technology from warfighting technology. There is a psychological side too, and militaries often underestimate it. If enemy crews and planners begin to believe that your ships are hard to finish, that belief spreads upstream into targeting doctrine, salvo size, mission planning, and political confidence. Weapons do not only work through physics, they work through expectations. A navy known for credible deception forces its enemy into caution, and caution is expensive. It means more missiles fired, more verification demanded, more hesitation before attack authorization, more pressure on already stretched logistics. That does not make deception some kind of magic fear ray, but it does mean the value of a decoy drone can exceed the one missile it diverts. If the enemy comes to expect that 1 or 2 missiles per salvo may peel away uselessly, then they must either accept worse odds or pay more for the same odds. Across a campaign that compounds, and compounding is the hidden engine of military advantage, not one dramatic moment, but 1,000 small forced inefficiencies. Decoy drones fit that logic beautifully. They create friction inside the attacker's plan, and friction is often enough to turn a confident doctrine into a nervous one. Now picture the worst case. The enemy combines missile attack with electronic attack. Your radar picture gets dirty. Communications get noisy. Track labels flicker between confidence and doubt. In that environment, the temptation is to simplify everything and rely only on hard kill responses. But that can be exactly what the attacker wants, because panic makes expensive decisions look emotionally safe. Decoy doctrine has to survive electronic chaos too. which means crews need pre-briefed trigger conditions and local logic, not just perfect centralized control. Maybe the ship loses part of its network. The decoy drones should still know what "protect the ship" means in geometric terms. Maybe the combat system cannot confidently classify all inbounds. The drones should still be able to occupy, likely intercept corridors, and present plausible signatures without waiting for a long conversation. This is why doctrine matters more than screens full of elegant icons. When the interface starts lying to you, doctrine is what remains. The whole point of modern naval survival is to keep enough structure alive when information is incomplete. Decoy drones are powerful because they can act inside uncertainty, but only if we design them and train with them as tools for chaos, not as accessories for perfect data environments. Let's return to the heart of the title: how decoy drones make enemy missiles miss. Not by magic, not by making missiles stupid. They do it by exploiting the fact that every guided weapon is really a chain of assumptions moving at high speed. The missile assumes the track is real. It assumes the strongest or cleanest return is meaningful. It assumes smooth tracking means true tracking. It assumes its final corrections are solving the right problem. The decoy drone exists to poison those assumptions at exactly the moment the missile can least afford doubt. And once you see it that way, the episode becomes simpler. A decoy is not a toy plane with a jammer strapped on. It is a machine built to attack confidence. That is why placement matters. That is why timing matters. That is why signature design matters. The whole battle is about making the seeker feel safe while guiding it toward a false conclusion. This is such a modern kind of warfare. Not brute force replacing intelligence, but intelligence shaping where brute force gets wasted. The missile still flies. The warhead still explodes. The physics still happen. The defender simply makes sure those physics happen in the wrong place. In practice, the smartest navies will not ask whether decoy drones replace interceptors. They will ask how decoy drones make interceptors more valuable. If one decoy removes one inbound from the hard kill queue, then your remaining interceptors suddenly protect more than their raw number suggests. If one decoy makes a missile arrive slower or off-angle, then your close-in weapons get a better shot. If one decoy forces the enemy to reveal seeker behavior, then your next defensive action is better informed. This is what integrated defense really means, each layer making the others less blind, less rushed, and less wasteful. So the future fleet probably looks less like a few giant ships surrounded by invisible faith, and more like a moving ecosystem of sensors, decoys, relays, and weapons, all cooperating to break the attacker's timeline. Big ships may still matter. Powerful radars may still matter. But a warship that cannot push deception outward is increasingly a ship that waits too long to start surviving. That is the doctrine shift. Hiding under all this hardware, protection begins farther from the hull than it used to, and the assets that buy that space do not need to sink enemy ships themselves to be decisive. Sometimes the most valuable drone in the battle is the one that dies pretending to be you. There is also an uncomfortable moral clarity to decoy warfare. A decoy drone is built to be spent. That feels cleaner than losing sailors, but it still requires a cultural shift inside militaries that love preserving assets. Commanders have to be psychologically ready to burn drones without hesitation, because saving a decoy for a better moment can become the reason there is no later moment at all. In other words, the decoy must be treated less like equipment and more like ammunition, something valuable precisely because it can be used up for effect. That matters for procurement, too. If procurement culture chases exquisite, over-engineered decoys that are too expensive to spend freely, the whole concept begins to rot. The best decoy drone may be good enough rather than perfect, cheap enough to deploy in volume, smart enough to be dangerous, and simple enough to trust. War has a brutal preference for systems that can be produced, understood, and replaced quickly. If decoy drones are going to shape the future fight, they need to live in that world. Not in a museum case of precious technology everyone is afraid to lose. The final operational lesson is this: decoy drones widen the defender's menu of choices, and survival often belongs to the side with more credible choices. Without decoys, a ship facing a missile salvo may have only a few options: jam, shoot, brace. With decoys, the ship can split the problem, misdirect one missile, delay another, expose a third, and save an interceptor for the one threat that cannot be fooled. Choice creates tempo. Tempo creates calm. Calm creates better decisions under fire. That may sound abstract until you imagine the opposite. One command team, one dense radar picture, one shrinking clock, and only one expensive answer available for every inbound object. That is not resilience. That is a trap disguised as sophistication. Decoy drones matter because they break the trap. They let the defender change the shape of the engagement instead of merely enduring it. And once a fleet can shape the engagement, it starts to regain the initiative, even while under attack. That is a profound shift, because initiative is usually thought of as something held by the attacker. Deception gives some of it back to the defender. So, if you zoom all the way out, decoy drones sit inside a bigger pattern we have been building all season. Saturation showed us that magazine depth matters. Detection taught us that early warning is fragile. Layered defense showed that no single ring is enough. Cheap interceptors attacked the cost problem. Picket drones pushed sensors outward. AI targeting attacked human delay. And now, decoy drones attack missile certainty itself. Each episode has been about the same war from a different angle. How to break the attacker's timeline before the attacker breaks yours. That is why this topic is bigger than one clever gadget. Decoy drones belong to a doctrine of distributed survival, a world where the ship is no longer a lonely steel target waiting to absorb the enemy's logic. Instead, it projects sensors, lies, reactions, and decisions outward into the battle space. The hull is still important, but the defense no longer begins at the hull. It begins out in the air, in the fog of the seeker, in the uncertainty of the enemy's final approach. Once you understand that, the old picture of naval combat starts to look incomplete. The modern ship is not only a shooter, it is a storyteller, and the story it tells enemy missiles can decide who comes home. But there is one final trap. Once both sides embrace deception, the battle space becomes crowded with lies. False targets, real targets pretending to be false, decoys that look like ships, ships that try to look smaller than they are. Missiles that switch seeker modes when they sense manipulation. Sensors feeding tracks that are technically valid, but operationally misleading. In that world, winning is not just about telling better lies. It is about protecting your own side from believing the wrong thing. And that takes us directly into the next layer of the story. Because the moment you use decoy drones effectively, the enemy has every incentive to poison your picture in return, to make your operators chase ghosts, trust the wrong track, or waste shots on a phantom. So the future fight is not only missile versus ship, it is truth versus confusion inside a machine-speed battle. Decoy drones solve one half of that equation by making enemy weapons uncertain. But your own survival still depends on something even more fundamental, knowing which picture is real when every sensor can be manipulated. The sound that matters most in modern naval war may not be the missile impact. It may be the split-second silence before impact, the moment when a seeker decides what it believes. Decoy drones live inside that silence. They're small, cheap, and often disposable, but they fight for the most valuable thing in the engagement, the enemy missile's confidence. Break that confidence, even briefly, and a weapon built to kill you can end up wasting itself on empty sky and cold water. That is the whole secret hidden inside the title. Enemy missiles miss because their certainty is not sacred. It can be bent, pulled, seduced, and broken. And that is where we leave this episode. Not with the fantasy of invulnerable ships, but with a harder, more useful idea. Fleets survive by making enemy systems solve the wrong problem at the wrong time. Decoy drones are one of the sharpest tools for doing exactly that. But once the battle space fills with lies, the next question becomes even more dangerous. How do you stop your own sensors from being fooled? In the next episode, we step into that fight, how sensor fusion stops poison tracks.